going to have a look at veins right now. Now, veins are often referred to as a capacitance vessels. If we go over here to the right hand of the slide, you can see a typical distribution of blood within the body. 18% in the pulmonary, 12 in the heart, 11 in the arteries, and 5 in the capillaries. And this shows that if you look at the veins, most of the blood, at least at rest, especially, is within the venous system. That's pretty surprising for most people. Most people think it'd be equally divided between arterial and the venous system. And that's why we refer to the veins as having high capacitance. So it has greater capacity for blood containment than the arteries. Now, typically, it doesn't experience the same pressure within the venous system, so you have thinner, flaccid, less elastic, and muscular walls. And often veins, I should say, collapse when empty, but they easily expand. And unlike, say, the aorta, the abdominal aorta, the aortic arch near the heart, where you get real pulsations of blood, in the venous system it's much more steady state, the movement. And of course the pressure is much lower. We have a much more significant reduction in the pressure in the venous system. Now, when you're following the venous system, of course, we're going to work our way from smaller to medium to larger vessels. And the postcapillary venules are the smallest of the veins. Interesting thing, they're actually even more porous than the capillaries. So we have exchange of fluid with the surrounding tissue even within them. They're tunica interna. There's some fibroblast, no muscle fibers at this point. And also this is a place where leukocytes can move from the bloodstream into the surrounding tissue when needed. Now as we move into larger veins and we're moving back towards the heart, we start to see the muscular venules, and they can be up to about 1 millimeter in diameter. Now once we get here, we're starting to see a little bit of smooth muscle showing up within there, and a thin tunica externa. Then as we go in further along, we run into the medium veins, and they're up to 10 millimeters in diameter. And we can start to see that the layers are starting to change a bit. We have a thin tunica media, and we have a thicker tunica externa. And we also start to have the presence of the venous valves made by the tunica interna. And of course, we could talk a bit about varicose veins, which are a failure of those valves. What helps to move the venous blood back? It's the skeletal muscle pump, which we talked a little bit about in class. We also have venous sinuses, and these are very thin-walled, large lumens and no smooth muscle. And the dural venous sinus, which we saw in the previous course when we were looking at things like the meninges, the coronary sinus at the back of the heart, which basically receives the venous blood from the myocardium itself. And they're not capable of vasomotion. And then we get into the larger veins. We're looking at 10 millimeters or greater. Some smooth muscle in all three tunics. Thin tunica media with a moderate amount of smooth muscle. And the tunica externa is the thickest layer, and it does have longitudinal bundles of smooth muscle here. Some examples, if you're thinking about these, is the vena cava, which of course very close to the heart, the pulmonary veins, the internal jugular, and the renal veins are some good examples there. I just want to mention a few things around veins, and of course often people hear about varicose veins. This is where the blood basically will pool, especially in the lower extremities of people. And one of the things that can do it is certainly stand for a long time. The actual column of blood, and especially if you stand still, the inaction of the skeletal muscle pump allows the blood to pool there. And of course this starts putting pressure on the cusps of the valves, and you end up with a weakening. And of course in the veins, I'll just draw quickly a vein here. If you really think about it, the veins are a series of chambers, and it goes back to our old concept, things move from high pressure to low pressure. But if I start to have a failure of some of the valves, then of course what happens is, think about that column of blood just gets bigger, and it becomes more difficult to move it along, and eventually we end up with basically a distortion of the veins themselves. And what can lead to this? It could be, as I said, often associated people that stand for long periods of time. Hereditary weakness, obesity, pregnancy also can have a role in this. And then there's a special type of varicose veins, and those are what people refer to as hemorrhoids. And these are veins, basically, in the anal canal. And we'll talk more about them when we get to the GI tract. Last thing I want to talk about a little about is the circulatory routes, or the general pattern. Most of us are familiar with the concept of blood leaving the heart. Blood goes into smaller arteries, arterioles, through capillary beds. Either the capillary beds open and the blood distributes through the capillaries, or it goes through through-fare channels and it returns. Well, in parts of the body there are other things we can see, or other circulatory routes. Another one is this. It's the portal system. In the portal system, you have blood in the arterial system. It goes to one capillary bed and then goes to a second. So one of the key features of the portal system is that in line you have a number of capillary beds, typically 2 capillary beds. Things like the hepatic portal system would be an example. Then we get into anastomoses, and we'll talk a bit about anastomoses in a second. But here's an example of an anastomosis, one type of anastomosis. You can see here that basically what happens is the blood vessel doesn't go through a capillary bed, and it hooks directly into another blood vessel, bypassing here. Now, some of these anastomoses are between, here we are, anastomoses. Right? We can have arteriovenous anastomoses, and that's where blood goes straight from an artery into a vein, and you bypass the capillaries. You can have venous anastomoses. These are more common. In this case, one vein empties directly into another one. And then you have arterial anastomoses, where 2 arteries will basically combine. And we've seen examples of those in the base of the brain, what used to be referred to as the circle of Willis at the base of the brain, and also in the heart to some degree. And this provides what we call collateral circulation, or collateral routes. And it gives an alternative blood supply for blood to go to the same location. Now we're going to end here, but the next video will pick up with the principles of blood flow.